The liar paradox. There's a famous sentence. This statement is false. It looks simple, but try to think about it. If it's true, then it must be false. But if it is false, then it must be true. We get stuck in a loop. This is the liar paradox. It shows that sometimes language itself breaks logic. Normally, we like to put everything into two boxes, true or false, but some sentences don't fit at all. Another version is, I am lying right now. If I am lying, then I am telling the truth. If I'm telling the truth, then I'm lying. The lesson: not every sentence is worth arguing about. Some are broken from the start. 2. The heap paradox, Sorites. Imagine a heap of sand. If we remove one grain, it is still a heap. Remove another, still a heap. But if we keep going, at some point we will only have one grain. And one grain is definitely not a heap. So where exactly did the heap disappear? That's the heap paradox. Words like heap, tall, bald, or rich are fuzzy. They don't have sharp boundaries. In daily life, that's fine, we understand each other. But in science or law, vague words cause trouble. That's why rules need exact numbers, like saying, a heap is 300 grains or more. 3. The grandfather paradox. Imagine you have a time machine. You go back to the past and stop your grandfather from meeting your grandmother. Then your parents wouldn't be born. And you wouldn't exist either. But if you don't exist, who traveled back in time? That's the grandfather paradox. It shows how time travel to the past causes contradictions. Some ideas to solve it. Maybe every change makes a new branch of history. Maybe the universe won't allow you to change the past. Events will always push you back to the same outcome. Or maybe traveling into the past is simply impossible. The paradox shows how fragile causes and effects are when we think about time. 4. The ship of Theseus. A ship needs repairs. One by one, every plank is replaced. When all the planks are new, is it still the same ship? If you look at the parts, then no, it's a new ship. But if you look at the history and the journey, it is still the same one. And here's a twist. What if someone collects all the old planks and builds another ship? Which one is the real ship? This is the ship of Theseus. And it's not only about ships. Our bodies replace cells all the time. After years, almost none of your old cells remain. Yet we are still the same person. So, identity isn't just about parts. It is also about history and meaning. 5. Zeno's paradoxes. Long ago, the philosopher Zeno argued that motion is impossible. One example: Achilles and the tortoise. The tortoise gets a small head start. Achilles runs to the place where the tortoise was, but in that time the tortoise moves a little forward. Achilles runs again, but the tortoise is still ahead. This repeats forever. So, how can Achilles ever pass the tortoise? The trick is that an infinite number of smaller and smaller steps can still take a finite amount of time. Math shows that Achilles catches up quickly. Another version is the flying arrow. At every single moment, the arrow is standing still in one position. If at every instant it is still, how does it move? The answer: motion is not about single frozen instants. It is about change across time. Zeno's paradoxes remind us that infinity feels strange. That's why we need math to explain it. 6. The barber paradox. In a town, there's a barber. He shaves everyone who does not shave themselves, and only those people. The question is, does the barber shave himself? If he does, then he is a man who shaves himself, so he shouldn't. If he doesn't, then he is a man who does not shave himself, so he should. Contradiction. This puzzle is a simple version of a bigger problem in math called Russell's paradox. The set of all sets that do not contain themselves. Does it contain itself? Yes and no at the same time. The fix? Be more precise with rules. For example, the barber shaves anyone who asks him to, then no problem. 7. The raven paradox. How do we test the rule, all ravens are black? It seems simple. Look at ravens. Each black raven confirms the rule. But logic says the rule is equal to everything that is not black is not a raven. So a green apple also confirms the rule because it is not black and not a raven. That sounds silly, but formally it works. The paradox shows that sometimes logic doesn't match our intuition. 8. The Monty Hall paradox. You are on a game show. There are 3 doors. Behind one is a prize. Behind the other 2, nothing. You pick a door. The host opens another door to show it is empty. Now he asks, do you want to switch? Most people think it is 50-50 now. But that's wrong. If you switch, your chance of winning is actually 2 out of 3. Why? When you first chose, the chance of being right was only 1 in 3. So in most cases, the prize is behind a door you didn't pick. When the host removes one wrong door, he is giving you a chance to switch to the winning one. That's why switching is better. 9. The crocodile paradox. A crocodile steals a child and says, if you guess what I'll do, I'll give the child back. The father says, you will not return the child. Now the crocodile is stuck. If he returns the child, the father guessed right, so he shouldn't return him. If he doesn't return the child, the father still guessed right, so he should return him. Either way, the promise is broken. This paradox shows how tricky self-contradicting rules can be. 10. The champagne bottle paradox. Imagine you go back in time and hand your younger self a bottle of champagne. Years later, you grow older and pass the same bottle back to your younger self. Where did the bottle come from? You didn't buy it or make it. It just goes in a loop from future to past and back again. This creates an object without an origin, and that breaks our sense of cause and effect. 11. The unexpected hanging paradox. A judge tells a prisoner, "You will be executed next week and it will be a surprise." The prisoner thinks, if it's Friday and I'm still alive, then the execution must be Saturday. But that wouldn't be a surprise. So it can't be Saturday. Then not Friday either, not Thursday, so it won't happen at all. But the execution happens suddenly, and the prisoner is shocked. The prediction came true. It was a surprise. This paradox shows how our reasoning can outsmart itself. 12. The Fermi paradox. The universe has billions of stars and planets. The chance of life out there seems huge. So where is everybody? Why don't we see signals, spaceships, or alien cities? This is the Fermi paradox. Some say civilizations are too far away. Others say they destroy themselves before reaching space. Or maybe we are the first. The mystery remains. If the universe is so big, why is it so quiet?